Hey, welcome back. Got a thermo quiz coming up in a couple days, so um, hopefully problems like this won't give you too much trouble. What mass of steam at 100 degrees Celsius must be added to 1 kilogram of ice at 0 degrees Celsius to yield liquid water at 20 degrees Celsius?
When I get all steamed up, hear me shout.
Yeah, I brought a friend with me. He's kind of messing with the videos a little bit, but it's all good. We're having fun. So the heat of fusion for water, in other words, the amount of heat that it takes to melt 1 kilogram of ice into water is 3.3 times 10 to the fifth. The amount of heat that it takes to evaporate 1 kilogram of water is this much, and the amount of heat that it takes to raise 1 kilogram of water by 1 degree Celsius is this many joules. So with that information, we can break the problem down. Okay, so I worked out the big picture of this problem for you, which it all comes down to energy. So you've got different steps where you have water being heated and being cooled, and you have ice melting, and you have steam turned into water, all sorts of stuff. But at the end of the day, it's just energy, because the energy that one object gains has to equal the energy another object loses. So the amount of energy gained by the ice that's melting and getting hotter is the amount of energy to melt the ice plus the energy to heat the water once all that ice is melted. So you have the heat gained by the ice, and the amount of heat that's gained by that ice had better equal the amount of heat that's lost by the steam. And you can break that down into its stages as well. Okay, so I have this set up a little bit more with the basic equation. So the way that I can write the energy lost by the steam is mv, where v is just the heat of vaporization. The energy from the steam cooling down after it turns into water is mc delta t. The energy used to melt the ice on the other side, because the ice is gaining energy, is mv. And the amount of energy to heat the water is mc delta t over here. So this whole chunk represents energy lost by the steam, and this represents energy gained by the ice. But one thing's for sure, they're both going to have a final temperature of 20 degrees Celsius. Now the thing that we're after here is to find out what mass of steam is required to do that. So we're looking for this value of m, but everything else we know. We know this, we know this, and this, and this, and this, and this, and everything on the right side. So we can actually factor the m out because it's in both of these terms. And these are all values we know, so we should be able to just crunch it in the calculator, which I'm about to do. Okay, so here comes the calculator part, but I want to point out one thing really fast. For this delta T, the ice went from a temperature of 0 to 20, but the steam went from a temperature of 100 to 20. So make sure for this delta T, you toss in a value of 80 for this one. And this one had a delta T of 20. Their delta T's are a little different, so make sure that that's consistent. But you get a much bigger number over here than over there. So you divide both sides to get the m by itself, and you end up with only a fraction of a kilogram. But then again, that makes sense, because check this out. The amount of energy that it takes to change steam back down into water is way more than the amount of energy it takes to melt ice into water. So we're not surprised that there was a lot more ice than steam involved in this thing. So the energy change is greater for heat of vaporization in the case of water.
Ice, ice, baby.
Oh yeah.